All right, a question came in for number 3 on the worksheet 2-7, and this one is a little confusing. It's got a bunch of stuff thrown at you, and it's kind of hard to make sense of it all. So I will slowly try to make sense as I go through and I read the problem. I realize the actual question they're asking me is they want to minimize the cost, and the cost is created right here by two types of food, X and Y. And so for me, that always tells me, all right, I know my goal is to minimize cost. So I want to minimize this cost where you're going to tell me how many X and how many Y I buy. And I do pay $12 for X and I do pay $8 for Y. So it just depends on how many of each one I'm going to buy. Right. So then I go through and I also start gathering some information like if you have a diet, vitamin A. So I'll introduce another variable, I guess. Vitamin A has to be at least 140. And vitamin B has to be at least 145. Okay, I got that. Then you break down some stuff about the two types of food, and here is X, and what X tells me is that they have 10 milligrams of A and 20 of B. All right, so that would have 10 milligrams of A and 20 of B, and Y would have 30 milligrams of A, so 30 milligrams of A, and 15 milligrams of B. All right. Now it looks like a mess, and I'm trying to think of what are my constraints. Well, going back to what we said beginning, right? We said A has to be restricted to more than 140, right? Well, here's the two combinations that would get you vitamin A. So the equation that I'm looking at is this: if you take 10 milligrams from product X and you get 30 milligrams from product Y, then that needs to be greater than or equal to 140. and then do the same thing with milligrams of vitamin B. If 20 comes from product X and 15 comes from product Y, and that's got to be over 145. There are my two constraints that will tell me how much X and how much Y I should buy. So I will call this X, I will call this Y, and I will plot this. So easiest way is to make Y as 0, so then X would be 14, so X is 14 for 1 point, and then the other point, if I make X to 0, then Y is 140 over 30, across the zeros, 14 over 3, what is that, 4 and 2/3, so that's a little more than 4, that's like here, that's like 4 and 2/3, right there, and so that is the graph. And now we want to be greater than that. So it's everything shaded up above that line. All right, what about the other line? Well, this one, let's say if I want to find the y-intercept or the x-intercept for that, I'd make y as 0. So 145 divided by 20. We think 145 over 2 is like 7. So it's like 7 something if you want the exact answer. 145 divided by 20 is 7.25. So there's 6 sevens like right here. So it's like right there. That's 7.25. And then the other one, 145 divided by 15. That should go in evenly. Nope, 9.9 and 2/3. So there's 10, there's 9 and 2/3. So 9 and 2/3. All right, I just like to know what they are because I usually need them again. So now there's the graph, right? Not the best graph in the world, but what it tells you is everything above here is feasible answers. Any X and Y combination in that blue region is good. So you're like, dang it, that's unbounded. So if we were trying to find probably a maximum, we're not going to find one, right? Because it's unbounded, it goes on forever. However, we're trying to find a minimum. I'm trying to minimize costs. So luckily, I just need one of these 3 points. There's one sitting right here, which I know the answer to because that was the point. See, it's blue. So that'd be 0, comma, I'm going to put it over here actually, 0, comma 9 and 2/3. Another point is this red one right here. And that was 14, so 0, comma 14. And another point that's bounding the region is this one. Notice those other 2 points aren't in the region, so I can't use them, is that intersecting point. And that one I actually have to find out. Now, what is it the intersection of? It's the intersection of these two equations right here. So, I don't know, multiply the top by -2. All right, so that'd be negative 20x minus 60y is equal to negative 280. And this one would be 20x plus 15y is equal to 145. Now I combine, I get 45y equals 135. And I believe that works out nicely to be 3. So y is 3, which means if I plug 3 in using systems of equation, I'll put it into this one. That'll be 90. That'll leave me 50. So x is 5. So there you go, right? So there are your 3 possible answers. Which one minimizes cost? Now, that shouldn't be too bad to use a calculator for. I can do, well, 12 times 0 is nothing. Plus, I wrote this other one wrong. Huh? This one was 14, 0, not 0, 14. So 9 and 2/3, so 9.66666, right? Times 8. The cost there is $77.33. So this setup would cost me $77.33. How about if I just buy 14 of product X? So 14 times 12, I think that's going to be more. That's $168. That's not a good deal. That's going to be expensive, but will get me at least some of the requirements I need. And last but not least, how about this one, which looks to be promising because 5 times 12 is 60. But wait, maybe not. Plus 3 times 8. Yeah, that's going to be $84. So to me, it looks like the minimizing cost would be buy 9 2/3. Now, what am I talking about? Food. So this is probably per pound. So yeah, 9 2/3 pound. I would buy that. I would go 0 of product X and 9 2/3 of product Y. And that would get me exactly what I need. So that would get me over the amounts for each thing, and at the same time would give me the lowest cost. Hope that helps. Stay happy.